Assalamu alaikum. Hi everyone. In this video I would like to share how do we describe and plot some functions like elementary functions and engineering functions that normally involve in the signal operations. Before that, let me give a brief introduction on the MATLAB software. So this is the MATLAB Windows, and it consists of a few sub-windows like on the top, left and right, and also in the middle. So up here we have the user interface menu. We have plenty of menus. On your left is the panel that shows our current working folder. So you can even create a folder. For example, you can right click on this panel, click on new folder, and you can name your folder, like for example lesson 1, and click somewhere, and you can double click on this folder and you are here in the lesson 1 folder. On your right is the workspace panel, and in the middle is the command window panel. After we enter values on the command window, MATLAB will store that value and display it in the workspace panel. For example, when we write, let's say a equals to 7, then hit enter. Okay, you will notice that in the workspace there is an a, which is the value equals to 7. Okay, as long as the value a is here, MATLAB will recognize that value. For example, you can even write, for example, b equals to a minus 3, and then you get 7 minus 3 equals to 4. So a and b are displayed at the workspace panel. Okay, the unique feature of MATLAB is all values and data are regarded as matrices or matrices. For example, we can write, let's say t equals to square braces 0 space 1 space 2 space 3 space 4 space 5 close braces, and then hit enter. So we get t equals to this array or matrix. So you can see in the workspace it is shown that t equals to this value. So this is actually a 1 by 5 matrix, a matrix that consists of 1 row and 5 columns. Even you can write something like c equals to, let's say the first row is 1, 2, 3, the second row is, for example, negative 3, 0, 1. So each rows are separated by semicolon, and then you can hit enter and you get this matrix C with 2 rows and 3 columns. Okay, to check the size or dimensions of a matrix, we can write this following command, which is size bracket, let's say t, and then MATLAB give the answer is 1 and 6. 1 refer to the number of row, 6 is the number of column because we have the first column, second, third, fourth, fifth, and sixth. And the size of C is 2 by 3, 2 rows and 3 columns, 2 rows and also 3 columns. Well, there is a more convenient way to define an array. For example, I want my t equals to 0, 1, 2, 3, 4, 5 up to 10, for example. So it will be what do you call, tedious to write a 0 space 1, 2 and up to 10. Instead we can use this short form command 0 colon 1 colon 10, meaning that starting from 0 and at 10, the step is 1. So you can enter, and then you get 0, 1, 2, 3, 4, 5, up to 10. So the size of t is now 1 by 11, as you can see in the workspace. Okay, now you can even write, for example, a function of t. For example, y equals to sine t. And then you hit enter. So you get this value for y. You can even double click on this workspace to check the data for y. So this is actually sine 0. This is sine 1, sine 2, and up to sine 10. For example, if I want to recall the y, let's say y4, so I supposed to get this value 0.1411. If I enter, I get, yes, exactly this value. So now we can even plot the graph y versus t. So let's close this Windows for a while, and you can write plot plot t comma y and hit enter. So you get a graph, the sinusoidal graph, y equals to sine t. But obviously this graph is not so nice because, because the step or the sampling is too large, which is 1. So to make it smoother, we have to reduce the value of the step of the sampling. Before that, let me clear this screen so you can write CLC and hit enter. So it's clear everything in the command window, but the variable in the workspace are preserved. So now we want to plot the graph y versus t with a even smoother shape. So we have to reduce the sampling of t. Now I want to write t equals to 0. The sample is now 0.01 up to 10. Okay, if I hit enter, I get this value. And now my t, as shown in workspace, the size of my t is 1 by 1001 because our sampling has been reduced to 0.01. Okay, if you don't like to display everything, the value for t in here, okay, you can end the statement with semicolon. Okay, and enter. Okay, if you write in this manner, you end one statement with a semicolon, it will not display the values in the command window, but the value is still stored in the workspace. Okay, now let's repeat the plotting. So now y equals to sine t. So I want to update y. Now if I hit enter at this moment, you will notice that the size of y will change to 1 by 1001. Okay, now we want to plot the graph y versus t. So plot t comma y, and now we have a much better shape of the sine wave. Okay, let's close this figure windows, and in MATLAB there are plenty of built-in functions like sine, cos, exponential, and so on. For example, we can write, let's say, x equals to exponent power negative t, or z equals to cos 2t. Okay, so this, sine, exponential, cos are built-in functions. And even we have some more special built-in function like zeros and ones. For example, if I write p equals to zeros 1 5, I get p, a matrix 1 by 5, in which all the entries or all the elements are zeros. Let's say I write q equals to ones presses 2 3. So I get a 2 by 3 matrix in which all the entries are number 1. But not all engineering functions or all what do you call the ordinary functions are built in by MATLAB. Sometimes we have to create our own functions using the MATLAB functions script. Okay, before we go into detail on the MATLAB function, let me show you a more convenient way to write the MATLAB codes, in which instead of using the command window, we can use the script. So you can create a new script up here in the Home tab, click on the new script, and it will open a sub window, a window which is known as M file sometimes. So we can write our program in this window and run everything at once. For example, I want to write my functions t equals to 0, 0.01, 10, my y equals to sine t. Actually, we can even copy and paste. Never mind. So z equals to cos 2t, and then I want to plot t x, plot t y, and plot t z. Okay, and we can run everything at once. So we can name our file, for example, basic function, or just basic, save, and the MATLAB will give you the figure. But if you notice, there is only one figure, which corresponds to function z. The reason is when we plot a new figure after one figure, it will overlap the previous figure. So the way to overcome it is by writing a figure command before the next plotting, so it will not overlap on the previous figure. So rerun the script and you get 3 figures. So figure 1 corresponds to exponential negative t, figure 2 is y equals to sine t, figure 3 is z equals to cos 2t. Okay, now let's consider other functions, other engineering functions like rectangular functions. Okay, before we proceed, I would like to explain that when you want to plot a two-dimensional functions, let's say y versus t, we have to ensure that y and t are one-dimensional. So especially our t. So our t must be in the form of vector, like we have done before, like 0, 1, 2, 3, 4, 5, which is in the form of row vector, or t equals to 0, semicolon 1, 2, 3, 4, 5. Whether t is a row vector or column vector, both cases are acceptable. So we can write function y equals to, for example, sine t. So my point is, at least row or column of T must be 1. So now let's continue with the script. Now I want to add one more function. For example, W equals to rectangular T, in which I wish to have a function like this. So we can check from the internet. This is the shape of the rectangular functions, in which when T or X equals to negative 0.1, negative 0.5 up to 0.5, the value of the function is 1. Otherwise, the value of the function is equals to 0. So we want to plot these functions in MATLAB. So I write W equals to rectangular T, and then I write figure and plot T comma W. So if I run this script, I get an error message because MATLAB said undefined function rect, because MATLAB doesn't know what is the meaning of rect. So we have to create or define our own function and name it as rectangular. So the way to create the function is, you can go to this menu, click on new option and choose function. So we have this. Okay, this is the layout of the MATLAB script to write the functions. Actually, we can change this. Let's say function f equals to the name of the function, which is rectangular. The input argument or the variable is t. And forget about this, never mind with the green text. This is actually a comment. We can even delete them. Now, how do we define the rectangular functions? So first of all, as I mentioned before, T must be a vector, whether row in terms of row or column, horizontally or vertically. So we need to check the size of T. So we can write m n equals to size T. So we need to ensure that 1 of m or n equals to 1. Okay, so we can, if 1 of m or n equals to 1, meaning that the user can proceed with the rectangular functions. So we have to check the value for m and n. So let's write let's say check vector, or you can write any variable equals to minimum between m and n. We want the check vector equals to 1. So we have to put a conditional statement. If the value for check vector does not equals to 1, okay, these symbols tilde equals means does not equals. So if 1 of m or n not equals to 1, we have to give an error message. So error input. For example, we tell the user that input to rectangular must be a vector. And then we end this conditional statement. Okay, now if one of m or n equals to 1, so another one must be should be more than 1 or even equals to 1, but it is not really practical. But for example, if we have a vector t 1 by 1001. So m equals to 1, n equals to 1001. So how to get that 1001 value is to get the maximum between m and n. So let's write k equals to maximum mn. So we know the size. So k equals to the size of the array. Okay, now we can initialize our functions. So let's write f equals to zeros m comma n. So at first we want all values for f equals to 0 because we wish to build these kind of functions. Let's say this is our f, this is our t, and f, all value of f equals to 0 except from the range t negative 0.5 up to 0.5. So initially we write all f equal to 0, and then we have to update the value for f between the ranges negative 0.5 up to 0.5. So for, let's say I equals to 1 up to k. Okay, if ti, the ith t, greater or equals to negative 0.5 and ti less than 0.5, we update the value for f should be equals to 1. So we end this conditional statement with n, and we end this for loop with n as well. So the purpose of this block is we want to update the value for f, because initially all value for f zeros, and then we want to change any value for f in between this range negative 0.5 up to 0.5, f supposed to equals to 1. So we can use double n symbol as suggested by MATLAB. And then we can save this function script, and we name our script with the same name of the function, which is rectangular. So we can save this window and you can even close it. So now you can notice that the rectangular script appear in our working folder. So go back to the basic script. So now we want to rerun our scripts. Previously we get an error message. Now if we rerun this, we have the graph for rectangular function w. But since the range of t is from 0 to 10, we cannot see the nice shape of the rectangular function, so we have to update t and close all figures for a while. I want to change the range for t is now from negative 5 to 5. Okay, and then we rerun everything. So now we can see the shape of the rectangular functions. Okay, you can even change the range of the axis, okay, to get a better look of your graph. Okay, to make a better presentation of our plot, let's say we have more than one graph like this. We have w, x, y, z. So we can plot everything on a single Windows. So this is known as subplot. So I can edit my script. So now I wish to have all 4 graphs displayed in the one window. So I wish to have my W here, X on my upper right, WX and Y on my lower left, and Z on my lower right. So I want to rearrange everything. So X, Y, Z. So W is here. So we can use the subplot command. So subplot 2, 2, 1. Okay, what means by 2, 2, 1 is our plot will consist of 2 rows, 2 columns, and the next plot will be located on the first the first entry in the plot. So plot TY. So axis, maybe you can do that later. Next, subplot 2, 2. Now number 2, which is function X. Next, number 3 and number 4. Okay, so if we run this script, we get all 4 functions plotted in the same window. So we have function W, X, Y, and Z. Okay, to make it even better, we can label all axes and even change the the range axis for any functions. Let's say for rectangular functions, I want the axis is from 0 to, let's say, 2, 0 to 2 for Y axis. So I can change here after plot TW, I write axis, open bracket, -5, 5 corresponds to the range for horizontal axis, 0, 2, that corresponds to the vertical axis. If I rerun my file, I get this. It's quite, I think it's better, even better than the previous plot. We can even label our axis. So okay, we can even label our axis by using the X label and Y label command. For example, after we define the axis, the range of axis for W, we can label the plot for W by using X label bracket, inverting comma bracket, and Y label, which corresponds to the horizontal axis, WT. And we can rerun everything, so we get this graph W. And we can continue with labeling for X, for Y, and for Z. Okay, if you want to change the range of axis, you can write this statement. If you want to just use the default range, you don't need to define the statement for the functions. Okay, so you can rerun your file and you get this W. This is X, this is Y, this is Z. So we have labeled all the subplot. This is W, graph for X, Y, and Z. Okay, you can even click here and you can right click and, for example, put some grid if you like. Okay, or you can remove it if you don't like. It's up to you. You can even change the color of the lines. I want to change this to, for example, red. Okay, this one, let's say green. This one becomes purple. Okay, or even we can change the thickness of the lines. For example, I want to change it to 2, and I get a thicker lines. And even the you can add some marker like this, but it's not really nice. Maybe we don't need the marker. How to remove it? None. Or sometimes we want to use a dotted line. Okay, so you are free to edit the plot. And now we have covered everything. So before we end this lesson, let's wrap everything. So now we have done all these 4 functions. So the first function is the sine functions, second is exponential, and then cosine functions, and this is special functions. We have to define our own function because rectangular function is not built in by MATLAB. So that's the reason we need to have a script for rectangular functions. For sine, cos, tangent, exponential, and other basics, some basics functions, they are all built in by MATLAB. Okay, so that's all for now. So thank you for watching.